first semester and second semester, this must be another university.
Ciao, I'm Edoardo from Rome, and I am a Mamaself student, almost finished. I'm finishing my master thesis in Rennes at the moment. I chose Mamaself at the beginning because during my bachelor thesis I got very interested in crystallography and diffraction, and I found this master a great opportunity to enlarge my knowledge in the topic while also continuing to learn other things about material science. And of course I really wanted to travel a little bit and be exposed to the educational systems of other countries. And I had the possibility for my first year to go either, being Italian, I had the possibility of going either in France, Montpellier or Rennes, or in Germany, in Munich. And I decided to go to Munich because I had a look at the courses which were available there, and I thought I was more interested in that. So I spent my first year in Munich, which of course was great. The university in Munich is one of the best, maybe even the best, I'm not sure, of the universities in Germany. And in fact, depending on whether you have a physics or material science background, you can go either to the Ludwig-Maximilians-Universität or the Technische Universität Munich. But even if you're a material scientist like me, for example, you are able to make the master course in the LMU, the Ludwig-Maximilians-Universität, but have 15 credits per semester for free to spend in either of the two universities. So I was lucky enough to then have courses of material science and crystallography in LMU, but free to take physics courses, more fundamental physics courses in the TU, which was extremely useful for my preparation. As part of our second year of Master Mamaself here in Rennes, on top of the lectures we are doing some experimental project that we are studying a material called vanadium oxide, V2O3. It has some interesting properties, including a phase transition from a metallic to an insulating state. And to study some of the properties, we are doing some X-ray diffraction measurements with this machine, which is a single crystal diffractometer. So we are using a small single crystal of vanadium oxide. We are putting it inside this very complicated and awesome machine. And then some X-rays come, interact with the atomic structure of the crystal and form a so-called diffraction pattern, which gives information on the position of the atoms in space. On top of that, because we are interested in this phase transition, which happens at low temperature, we are using some nitrogen to cool the crystal down, and the nitrogen is contained in this tank. It flows and it hits the specimen, which is a very small crystal, more or less there, and cools it down so that we can conduct a diffraction experiment also at low temperature and see the difference between the high and low temperature phase.
Real weight statistics. So imagine that we are slightly smaller than this, maybe we do not hit all the samples. But then we do not only reduce the background, we also reduce the scattering intensity. So maybe this is part of it, so we will put back.
So, for my second year, I went to the University of Rennes here in Rennes, obviously. And for the first semester, I attended courses in the university mainly related to either materials chemistry, material science, or material characterization. So, for example, we had, in terms of material characterization, we had courses in X-ray diffraction and NMR, nuclear magnetic resonance. And the courses in Rennes are divided between courses which are given from the chemistry or physics school and courses which are attended in the engineering school along with other French students. Attracts the halogen atom close to the cell and changes the halogen to metal distance. Now, how about in a charge density wave state with increasing temperatures, just as the other one did. And in terms of the chemistry of this compound, we have this palladium cyclopentane diamine bromide, which is formed again by a palladium atom, which is the metal atom in this case, and a bromine. alternating along the chain, and this. The second semester of the second year here at Mamaself, students have the possibility to go and carry out research for the master thesis in several institutes all over the world. However, I decided to stay here in Rennes because I was very much interested in the kind of research that the group here at the Institute of Physics was doing on a type of crystallography which is highly theoretical and relies very much on data analysis, which is one of my passions. And so I decided to stay here, and now I just had my defense, and I had just to hand in my dissertation and then I'm finished.